Now we will have a look on the first part of the CRO, the electron gun. It's a modified version of the cathode ray tube. The first modification is made to the anodes. The anodes here are two hollow tubes instead of a closed plate. This is to allow the passage of the accelerated electrons through it to the deflection system. The second modification is adding a grid. The grid is a metal ring that is connected to a negative potential. This negative potential is controlled by a controller button on the interface of the CRO. This button is the brightness. Adjusting the button will adjust the negativity of the grid, and hence the amount of repulsion between the negative grid and the negative electrons. This in turn controls the thickness of the beam of the electrons, which finally affects the brightness of the spot that will appear on the screen at the end. And this is simply the second part of the CRO is the deflection system, a system that is responsible for the deflection of the beam of electrons from its original straight line path. The deflection system consists of two parallel horizontal plates named as the Y plates. The Y plates are electrically connected to the interface through two openings named the Y input. This is where we apply our signal, or the voltage to be drawn by the oscilloscope. The signal can be as simple as a DC battery, or as complex as sound captured by a microphone. Also, they are connected to a button to control the amount of deflection by the Y plates. This button is named as Y gain, or sometimes the voltage scale. As a simple example to understand the function of the Y plates, let's connect a DC battery to the Y input. This will apply a voltage on the two plates, so the upper will be positive and the lower is negative. This causes the deflection of the beam of the negatively charged electrons upwards, repelled from the negative plate and attracted to the positive plate. For more understanding, now reverse the connection of the DC battery. The plates will reverse their potential and the beam will be deflected downwards. This appears on the screen as a spot that is lower in position than the center of the screen. Remember that if the battery is removed and no signal is applied to the Y input, the bright spot will return to the center of the screen. The second part of the deflection system is the X plates. To understand the basic rule of the X plates, we must remove any signal from the Y plates. Unlike Y plates, the X plates are not controlled by external signals or inputs. X plates work by a signal from inside the CRO. The value of the signal is controlled by a button on the interface. This button is named as the time base. As long as the time base is off, there is no voltage applied to the X plates, and the spot is in the center of the screen. When the time base is having any value other than 0 or other than being off, an inside signal from the CRO named sawtooth voltage. This voltage causes the deflection of the beam across the screen, left and right with high frequency. This will appear on the screen as a horizontal line. The third part of the CRO is the fluorescent screen. The screen is covered from inside with a material that is sensitive to the electrons. When electrons fall on the screen, it gives a bright light in the position where the electrons hit the screen. This appears from the outside as a bright spot. The screen is divided into squares like a graph paper, so we can take our measurements as we will see later in the examples.